Okay, so we're going to work from left to right on here because the multiplication and division are really equivalent. So it'll be 36 minus 6 times 3 plus 1, which would be 36 minus 18 plus 1, which is 19, and that should be your final answer on that one. When you're doing a prime factorization, you need to use a factor tree. There's other ways of doing it, but that one seems to be the easiest way for me. So I already know that it's an even number, so 2 goes into it. So I'm going to divide it by 2. I have 2 and 126 here. Once again, I know that 2 goes into it. It's 2 and 63. 63 can be divided by 9 and 7, and then 3 and 3. So to write out my prime factorization, this is what it should look like. You can either write it as 2 times 2 times 3 times 3 times 7, or you could write it as 2 to the second, because it's twice, 3 to the second, and 7. Okay? Now, on the quiz, it's multiple choice, and they could write it either way. Just know that those two things mean the same thing. Any questions on that one? All right. Now, you have to use a factor tree to find the least common multiple. Generally, I call this the LCM, just to save time. I did a factor tree of 240. Notice it ends in a 0, so I took out a 10, just to make it a little easier and quicker. And then divided it all the way down to, I have 4 2's, which is what I reflected over here, a 3 and a 5. Same thing with 284. Now, with least common multiple, you're going to need to represent each prime number that is found in both of these. So I found a 2, I have a 3, I have a 5, and I have a 19. All 4 of those need to be represented. But now at this point, once I have them represented once, I need to pick the largest representation. So how many 2's are represented up here? A 4. Yeah, 4 times. How many 3's are represented? Just once on each one, right? So that's going to be a once. 5 to the 1 and 19 to the 1. If you multiply that out, you actually get 4,560. I didn't think that this was a very good example of least common multiple, so I'm going to give you another one. Okay? So up in somewhere that you have some space, I want you to write down this example. Say I have a prime factorization of 2 times 2 times 3 times 3 times 3. And say I have another one of 2 times 2 times 2 times 3 times 5. To find my least common multiple, what I want you to do is, first of all, represent each prime. So what primes do we have? A 2, a 3, and a 5. That's the first step. Next, I want you to find the largest representation of each. How many 2's do I have? That's the largest representation. 3. So this will be 2 to the third. What's the largest representation of 3's that I have? 3. What's the largest representation of 5's do I have? 1. Okay? So that is the basis of your least common multiple, and then you have to multiply that out. Okay? So, least common multiple, largest representation. Okay? Greatest common factor, which we will come to later, is matched primes. Okay, if you can remember those two differences, it'll help you a lot tomorrow. All right. Any questions about that one? I hope that helps you. All right, so now coming down here, we're looking at less than, greater than, less than and equal, or greater than and equal. Well, negative 2 on the number line is to the left of 7. Okay, so it's definitely less than. When you have two negatives, it's tricky because people get mixed up in their mind because 13 is a bigger number than a 1, but it's further down to the left on the number line. So that is the less than there. Okay, on this one right here, we have 6 11ths and 7 12ths. One little trick on this. If you notice that the numerator is just adding 1, so it goes from 6 to 7, you're adding 1 on the numerator. Look at the denominator. I'm doing the same thing here, adding 1 to it. So it's automatically going to be less than, the smaller one is going to be less than over here because it's a smaller number. That goes true for this. What if I had 2/3 and 1/2? Which one's smaller? The 1/2, notice because it's only down by 1, both the numerator and the denominator. What if I had 78 90 and 79 91? Which one's smaller? Yeah. Okay? So that's one way. If it's only a difference of 1 on top and bottom, you can do that. If it's not, then you have to actually divide it and find the decimal of both and figure out which one's smaller that way.
Did you find like the greatest, or the common denominator?
You can do that too. Yeah, exactly. It's another way of doing it. So, if I take this one, good point. If I take, I don't know what my greatest common denominator is on this, so if I take both by 12 and this one by 11, all right, so 11 times 12 is what?
121?
No, 121 is 11 times 11. So 121 plus 11 is 132. Okay, so it'll be 132 on the bottom. And 12 times 6 is 72. And then 77 over 132. So which one's bigger? Obviously that one. Okay, so yeah, finding greatest common denominator. That's another way of doing it. Okay, absolute value. Absolute value is the distance from 0. So negative 14 is 14 from 0. Negative 300,000 is 300,000 from 0. And absolute value of 0 is 0. Oops, sorry about that. Go back. Converting this number into a mixed number, first of all, I recommend that you take the negative outside and put parentheses inside. Find out what the mixed number is first and then reapply the negative. So 76 divided by 9, if you do long division here, 8 goes into it, 72 times 7, 8 times 9 is 72. Subtract it, you got 4 left over. Clockwise, you have 8 and 4/9, and reapply the negative. Any questions? All right. All right, so now I want to talk to you guys about how to do this one. This one was worded in a way that kind of threw people. But basically what it's asking you, it's saying, how many equal stacks can I make for both the 5s and the 10s? It needs to have equal amount of bills in each stack. So if you're trying to find the equal amount of bills, you need to find the greatest common factor. Okay, so here we do the GCF. We're going to find our factor tree. And basically I came down to 31, 2, and 5 for 310. For 460 I came down to 2, 23, 2, and 5. Remember earlier I said GCF, you're matching primes. So notice I have highlighted here, the 2's are highlighted, they match, and the 5's highlighted. There's nothing else I can pair with. I can't pair this 2 with the 2 on the 310 because there's not another 2 to pair it up with. So if I take 2 times 5, that's equal to 10. So that's the number of bills in each stack. It's 10 bills in each stack. 10 bills in each stack. And there's going to be, so if you have 10 bills in each stack of $5 bills, how many stacks are you going to have? No, if you have 10 bills in each stack of 310 bills, you're going to have 31 stacks of 10, right? And then 460, you'll have 46 stacks of 10. So 10 is your answer on this. So on this one it says express the following rational numbers as decimal. These are easier than what we did earlier today with those 2-digit numbers. You're going to take 7 into 22. Okay? How many times does 7 go into 22? 3. 3 times 7 is 21. I subtract that, and I have 1. Put the decimal right here. How many times does, well, first of all, I'm going to bring down a 0. How many times does 7 go into 10? Once. 1 times 7 is 7. I have a 3. Bring down another 0.
4.
Yep, 4. 4 times 7 is 28. 20. 2. You can keep going. This goes on for a long time. Do you guys recognize this number? It's like pi. This is the closest approximation to pi that you can get with a rational number. Okay? So that's what this is. So I'm going to leave it at 3.142. It goes on for a long time. Okay. So that's how you do that. Do the same thing for the 9. I should have left that up there. I'm sorry, you guys. Oops. Did I set that up right? No. This is a common error. So what we're actually doing is we're dividing 9 by 11. So 11 does not go into 9, but it goes into 90. How many times does 11 go into 90? 8. So 8 times 11. Okay. So I'll bring down a 0. How many times? Once. 90 again. 8. You guys see a pattern going on here? So it's repeating. So the answer on this one should have been 81 repeating. All right. Quotient of integers. You guys, in simple English, that means fractions. Okay, so it says take these decimals, turn them into fractions. Okay, so what place is that 2 in? Hundredths. So I'm going to take 82 divided by 100. That's not in simplest form, so I need to make that in simplest form. It's 41 over 50. What place is this 5 in? 1,000. So I'm going to take 725 over 1,000. Simplify it, I have 29 over 40. Any questions about those two? All right, we're looking at repeated decimal. Notice it's 257 repeated, right? 3 digits. So the algorithm that we use for this is, first of all, you need to set this equal to n. So n equals 0.257 repeating. I'm just going to put the bar over the top. Okay, since I have 3 digits, I'm going to multiply both sides by 10 to the third. The 3 zeros representing the 3 digits. Okay? So this becomes 1,000 n equals 257.257 repeating. Now we are going to take that first equation and subtract it from the second. So I'm subtracting n from that side and subtracting 0.257 repeating from this side. That gets rid of the repeats. So now I have 999n equals 257. If I divide both sides, this is my final answer. Okay, so on this next one, we have a mix of 8 servings of instant potatoes, and it requires this much of water. What we need to do is take these and divide them into 1 serving apiece. So we have 8 servings, and this is how much we need for 8 servings. So we need to find out how much it is for 1 serving. So to do that, we have to divide this by 8. And guess what? You do use this. I use this cooking all the time. If you cook, you will be using this. Okay, so 2 times 3 plus 2. It's 11 thirds divided by 8. Okay? Yep, you're going to multiply instead by 1 over 8 because you flipped the second one. Wait, did I do something wrong? Yeah. Yeah. I was like, wait a second, something's wrong here. Okay. So now I can pre-reduce this. Notice that there's 8s in the diagonal. I can get rid of that. So this is 1/3.
For 1 serving?
Yep, for 1 serving. So we need to make it into 11 servings. Multiply it by 11. So it's 11 thirds. Okay. And then once you have that, you can make that into a mixed fraction. 3 goes into 11 how many times? 3. 3 times 3 is 9. You have 2 remaining. So it'll be 3 and 2/3.
You can just multiply 11 eighths.
Yeah, you can do that and to reduce it, right? So it'll be 88. But if you pre-reduce it, it makes it a little easier. Okay, so this one, convert -7 and 3/5 to an improper fraction. Put that negative on the outside. Okay, so that would be the same thing as saying 7 times 5, 35, plus 3 over 5. So it'll be -38 over 5. All right. The next one's a bit harder. And I'm going to try to do my best to give you a visual picture of how to do this. So first of all, if you were to make a numbered line, here's 0. Okay, so here's 1 and here's -1. -2/3 is somewhere like this. And 5/6 is somewhere right here. What it's asking you is to find the where it is exactly on the number line that's halfway between them. No, it isn't. It's close, though. It's a good approximation. 0 is close. So what we need to do is find the distance between -2/3 and 5/6 first. Okay? So we got 5/6 minus a -2/3. Okay, so first of all, I'm going to multiply top and bottom of this. So it'll be 5/6, and this is a negative, 2 negatives, so I'll make it a positive. It'll be 4/6. 9/6 is my answer. It is 9/6 apart from each other.
Can we simplify that or no?
We can, but I'm going to recommend you not doing it until the very end because we're not done yet. We found the distance. We need to find the halfway point.
Yeah.
So we're going to multiply by 1/2. So it'll be 9/12. So now I know that from this point, if I add 9/12 to that, I will get the halfway point. So that's the next thing we have to do. We're going to take -2/3 plus 9/12. Multiply top and bottom by 4. We have -8/12 plus 9/12. The answer is 1/12. It's very close to 0, Sam, but not quite there, but it's very close. Okay? 6 goes into 74/94 because 2 and 3 both do. The last 3 digits is 128, and 8 goes into that, so that's true. And here's the rest of your answers here.